Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2019. The question is from the topic of collisions. It was one of the better questions in this paper, which stumbled many of the good students as well. So let's see what's happening over here. This is a particle which is moving at a speed v. V is the instantaneous speed. The particle is moving inside a very narrow tube which is smooth, and the instantaneous distance between the left end of the tube and the piston, which is also moving at a speed of Vp. Actually, it is given capital V, but so as to differentiate between the speed of the particle and the piston, I'm writing this as Vp. So remember, this is not the speed of the particle, it is the speed of the piston. So Vp is the symbol I'm taking for the piston, right? So what happens whenever particle goes and strike the piston, it there's an elastic collision, and after the elastic collision, the particle returns and again goes back to this left end. There's also one condition given. So this is Vp, velocity of the piston. So this is one condition given, that Vp is much less than dl by L, where dl is the distance moved by the piston in like small distance moved by the piston. Okay, so we will see the use of this condition as well. Why do we need this condition? So piston is being moved very slowly inside this tube, and instantaneous distance is L. So initially the distance was L, L has the had the value of L naught. Okay, and initial particle speed was V naught. When the value of L was L naught, at that instance the speed of the particle was V naught. Okay, so we have to check some options that after every collision the speed of the particle is going to increase by 2v. If the piston moves by a certain distance dl, then the speed of the particle is going to increase by this much amount, 2v dl by l. Okay, then the particle kinetic energy will increase by a factor of 4 if the distance between the piston and the left end of the tube becomes half, and the rate at which particle strikes the piston. So these are the options that we have to check. Now, first option is pretty obvious. If you think carefully, then we can say that after every elastic collision, the speed of the piston is going to increase by, sorry, speed of the particle is going to increase by 2v, because it's very heavy. Piston is very heavy. This is also given in the question. So piston is very heavy in comparison to the particle. How can we prove this? By the way, this is a standard result. But if you want me to prove this, then we can prove this by an argument itself. If you stand on the piston, so this particle is going to move with the speed of v plus vp, right? And in the frame of piston, piston will not move. Now, since it's an elastic collision, so particle is going to return with the same speed, v plus vp, correct? In the frame of piston. So in the frame of piston, if it returns by this speed, that means in the ground frame, it is moving at a speed of 2 v plus 2 vp, correct? Hence, now you can see if it comes at v and in the ground frame it comes at v and it is returning at v plus 2 vp. Therefore, we can say that the increase in the speed of the particle per collision is 2 vp. Right? By the way, this is a standard result, so many of you might be knowing this as well. Hence, option A was right. After each collision with the piston, the particle speed will increase by 2 vp. So remember, capital V is vp actually. Now, if piston moves, let's check for the some other options. Now, if I draw the figure, just let's say this is the piston for the time being, and this distance is L at the moment, and this particle is moving at a speed v, and piston is moving at a speed vp, which is very small. Now, if you remember, there was one condition given in the question: v is much less than dl by l v naught. Now this is vp actually, which is much less than dl by l into v naught. V naught is the original speed of the particle. Now let's see what this condition means. So if you write this, if you take vp on the right side and remaining terms on the left side, so this will become L upon V naught. Now, if you see, this is the distance, this is the time taken by I think equality sign will be opposite. Yeah. So like this. This is the time taken by the piston to move a slight distance dl, distance upon speed. So this is the time taken by the piston to move a very very small distance dl, and this is the time taken by the particle, we can say, to move one of the one, like from this to this side, वन वे मोशन, एक तरफ जाने का मोशन है, एक तरफ जाने का टाइम ये लिखा हुआ है फॉर द पार्टिकल. So this time is very very large in comparison to this time. So what does this imply? This implies that by the time piston moves slightly ahead, this particle would have made lot of collisions. Dhad, 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 dhad. So it would have made number of collisions. Dhad, 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 dhad. So we can say that, you know, the frequency of the collisions will be very very high, right? Now, frequency of the collisions. So basically, after how we will write frequency of the collision? Frequency of the collision is very simple. We can say that, number of collisions per second. So how much distance does it move in 1 second? Particle, it moves v distance in 1 second, because speed is the distance per second. So we can say that we can say that v, basically this is the speed of the particle divided by 2l, right? Because for traveling, for one collision it needs to travel 2l distance to and fro we are talking about. So frequency of the collision will become v by 2l. Okay, and what is the increment in the speed of the particle? What is the increment in the speed of the particle per collision? So increment in the speed of the particle per collision is 2vp. So remember, this is the number of collisions per second, and in one collision this is the increment in the speed. So can we say that rate of change of velocity of the particle is nothing but this only, v by 2l into 2vp? Think, this is the number of collisions per second. एक सेकंड में कितने collision हो रहे हैं, and एक collision में कितनी speed change हो रही है. So that means this is the total rate of change of speed or velocity, we can say. Okay, 2 and 2 will get cancelled. This is v into vp upon L, right? This is v into vp upon L. Before doing further, we have to check one option. If the piston moves by distance dl, the particle speed increases by this amount. So let's see if this option is correct or not. So can we write vp into vp dt को अपन dl लिख सकते हैं क्या? vp dt को we can write dl. ठीक है, dt टाइम में अगर पिस्टन dl डिस्टेंस आगे मूव कर रहा है, so we can write vp dt as dl. So dv will be is equals to v by L into dl, correct? So what do we get? If the if the piston moves by distance dl, the particle speed increases by 2v into dl by L. So how much is the increase of the speed? We can see that increase in the speed of the particle is v by L dl, not 2. अगर यहाँ पे 2 आता, then option B would have become correct, but option B is wrong. ठीक है? So this is the equation that we are getting. This is the equation that we are getting. Now we can integrate this equation. One more thing, we have to put minus sign over here. Why do we need to put minus sign over here? In reality, L is decreasing with time, okay, and V is increasing with time. So that means we have to put minus sign. Okay, so reality में ये जो VP है, that is minus dl by dt. Velocity of piston is minus dl by dt. So that's why we need to put minus sign. Okay, so now when we integrate this, initial value was L naught, initial speed was V naught. We have to find the kinetic energy when particles when distance becomes L naught by 2. So we can say that when distance becomes L naught by 2, let's say speed becomes V. So here it becomes ln of V by V naught will be equals to minus ln of half, because L naught by 2 by L naught करेंगे तो वो half ही आ जाएगा. Okay, so this will become ln 2. So V by V naught will become 2. ठीक है, so V will become 2 V naught. Hence we can say that speed of the particle has doubled when the piston has moved to half distance. So which implies kinetic energy would have become 4 times. Kinetic energy would have become 4 times. So this option is correct. Option C is correct. Rate at which particle strikes the piston, we have already found this is nothing but frequency, which is V by 2L. Rate of collision is frequency of collision, which is V by 2L, which is option D is wrong. So we can say that option C and option A were the correct options. So I hope you would have understood the solution. That's it. Thank you.